OpenGL Shading Language is a high-level shading language based on the syntax of the C programming language. It was created by the OpenGL ARB to give developers more direct control of the graphics pipeline without having to use ARB assembly language or hardware-specific languages. Background: with advances in graphics cards, new features have been added to allow for increased flexibility in the rendering pipeline at the vertex and fragment level. Programmability at this level is achieved with the use of fragment and vertex shaders. Originally, this functionality was achieved by writing shaders in ARB assembly language, a complex and unintuitive task. The OpenGL ARB created the OpenGL Shading Language to provide a more intuitive method for programming the graphics processing unit while maintaining the open standards advantage that has driven OpenGL throughout its history. Originally introduced as an extension to OpenGL 1.4, GLSL was formally included into the OpenGL 2.0 core by the OpenGL ARB. It was the first major revision to OpenGL since the creation of OpenGL 1.0 in 1992. Some benefits of using GLSL are cross-platform compatibility on multiple operating systems, including GNU Linux, Mac OS X and Windows. The ability to write shaders that can be used on any hardware vendor's graphics card that supports the OpenGL shading language. Each hardware vendor includes the GLSL compiler in their driver, thus allowing each vendor to create code optimized for their particular graphics card, unregistered trademark S architecture. Versions: GLSL versions have evolved alongside specific versions of the OpenGL API. It is only with OpenGL versions 3.3 and above that the GLSL and OpenGL major and minor version numbers match. These versions for GLSL and OpenGL are related in the following table. Operators: the OpenGL shading language provides many operators familiar to those with a background in using the C programming language. This gives shader developers flexibility when writing shaders. GLSL contains the operators in C and C++, with the exception of pointers. Bitewise operators were added in version 1.30. Functions and control structures: similar to the C programming language, GLSL supports loops and branching, including if-else, for, do-while, break, continue, etc. Recursion is forbidden, however. User-defined functions are supported, and a wide variety of commonly used functions are provided built-in as well. This gives the graphics card manufacturer the ability to optimize these built-in functions at the hardware level if they are inclined to do so. Many of these functions are similar to those found in the math library of the C programming language, such as EXP and ABS, while others are specific to graphics programming, such as smooth step and texture. Compilation and execution: GLSL shaders are not standalone applications. They require an application that utilizes the OpenGL API, which is available on many different platforms. There are language bindings for C, C++, C, Delphi, Java and many more. GLSL shaders themselves are simply a set of strings that are passed to the hardware vendor's driver for compilation from within an application using the OpenGL API's entry points. Shaders can be created on the fly from within an application, or written as text files, but must be sent to the driver in the form of a string. The set of APIs used to compile, link, and pass parameters to GLSL programs are specified in 3 OpenGL extensions, and became part of core OpenGL as of OpenGL version 2.0. The API was expanded with geometry shaders in OpenGL 3.2, tessellation shaders in OpenGL 4.0 and compute shaders in OpenGL 4.3. These OpenGL APIs are found in the extensions, ARB Vertex Shader, ARB Fragment Shader, ARB Shader Objects, ARB Geometry Shader 4, ARB Tessellation Shader, ARB Compute Shader. Examples: A sample trivial GLSL vertex shader equals. This transforms the input vertex the same way the fixed function pipeline would. Note that ftransform is no longer available since GLSL 1.40 and GLSL ES 1.0. Instead, the programmer has to manage the projection and modelville matrices explicitly in order to comply with the new OpenGL 3.1 standard. A sample trivial GLSL tessellation shader . This is a simple pass-through tessellation control shader for the position. This is a simple pass-through tessellation evaluation shader for the position. A sample trivial GLSL geometry shader . This is a simple pass-through shader for the color and position. Since OpenGL 3.2 with GLSL 1.50 geometry shaders were adopted into core functionality, which means there is no need to use extensions. However, the syntax is a bit different. This is a simple version 1.50 pass-through shader for vertex positions. A sample trivial GLSL fragment shader . This produces a red fragment. In GLSL 1.30 and later you can do where program your shader programs handle 0 color buffer number associated with the variable. If you are not using multiple render targets, you must write 0. myFrag color name of the output variable in the shader program, which is associated with the given buffer. See also, Standard Portable Intermediate Representation, an intermediate shader language by Chronos Group, 3D Computer Graphics, Chronos Group, WebGL, an OpenGL ES dialect for web browsers, which uses GLSL for shaders. Other shading languages ARB assembly language, a low-level shading language, CG, a high-level shading language for programming vertex and pixel shaders, HLSL, a high-level shading language for use with Direct3D, TGSI, a low-level intermediate language introduced by Gallium 3D, AMDIL, a low-level intermediate language used internally at AMD. References, Notes. Books, Rost, Randy J. OpenGL Shading Language. Addison Wesley. ISBN 978-0-321-63763-5. Kesenish, John. Baldwin, David. Rost, Randy. The OpenGL Shading Language. Version 1.10.59. 3D Labs, Incorporated Limited. External links, OpenGL Fragment Shader Specification, OpenGL Vertex Shader Specification, OpenGL Shader Object Specification, the official OpenGL website. IDE RenderMonkey, OpenGL Shader Designer, Mac OpenGL Shader Builder User Guide, Shader Maker, PolyDraw, Quick Shader on SourceForge.net.